Hello, hi everyone, welcome to Cloud Sprint. Hope you are doing good today. As we are progressing in the course of GCP ACE, I thought there are a few topics which are really important while working on cloud as well as for the exam also. You might expect 2 to 3 questions from this video in your exam. Topics which we are going to cover are custom machines, preemptible VMs, images, and snapshots. These 4 topics are very important while you work with compute and while you design systems in your respective job or career. So let's start. So you have two options while creating a compute instance. Number one are standard configuration machines, and second is custom machine types. Custom machines are basically where you can choose how much CPU versus how much memory you need. And any need is not being fulfilled by the standard machines. We go ahead with custom machines, and then we choose the CPU and memory. The benefit of this is mostly around cost. You don't waste resources. Suppose you need 20 GB of memory, you'll choose 20 GB of memory. You are not going to use 80 GB of memory. Custom machines from via API as well. That's very simple command. When we do gcloud commands, I'll showcase this. Apart from that, it supports almost all the OS. Okay, you can create, you can programmatically access and assign how much custom memory or custom CPU you want to give, and you can create it on the fly. Why don't let's check it at a lab. Okay, let's check it now. You already know how to create VMs. I'm just gonna show you how to make custom machine. And there's machine family for different purpose. Then there's series, and then there's machine type. When you select a series, it comes with standard predefined resources. Okay, like N1, N2 standard 2, N2 standard high mem, N2 N2 high mem 2. These kind of options you have. Okay, suppose if I choose this, I have 96 GB of CPU, 96 GB of memory. If I choose this, then I have 4 GB of CPU and 16 GB of memory. I cannot change this. But suppose there's a requirement, you are running a memory hungry process, you need less CPU but much more memory than offered. What you'll do, the one solution could be use a higher configuration. This higher configuration will give you more CPU, more memory, but you'll waste the resources. As a cloud engineer, you should make sure that you're optimizing the cost, you're saving the money while creating resources. To solve this problem, GCP gives us an option of creating custom machines. Okay, here you can adjust with N2 series custom machine. You can have up to 80 vCPUs and up to 650 GB machines. The more memory you want to increase, you can say the price changing. Okay, you can see the more CPU you are shifting, this number is increasing. Okay, to compensate that. So suppose you need, as I mentioned, you need less CPUs and more memory. So what you can do, you can keep your vCPU to 36 and increase the memory to 288 GB. Okay, this is where how you are saving money on CPU and you're utilizing the memory of the VM to the maximum extent, and you are saving on money as well. If you would have gone with a default value, you can see this $1,400 will become 2,200, right? So straight away a lot of saving for monthly. If you calculate this money yearly, it will be a lot of money, and these processes you'll be running day in and day out. So you can see the difference why custom machines are very powerful. The rest of the process remains same, so you can just go ahead, click create. This will create a VM. I'm not creating because that's not important. You already know how to create it. We create a VM. Just note one thing, this custom option is not available with these options. Like if you go to compute optimized, there is no custom option. Memory optimized, no custom options. This custom option is only available with general purpose machine, and not all of them, but with E2, N1, N2, N2D. These series have custom machines options. So you should always know that how much load you're gonna take, and that's how you configure your machine to save your cost. That's all about custom machines. The second topic is Spot VMs or preemptible VMs. Preemptible VMs are just highly affordable compute instance suitable for batch jobs or fault tolerant workloads. So what happens, cloud providers have a lot of VMs lying idle. They offer those machines at a cheap price. So you can use it But whenever they need them, the cloud providers, whenever they need them, they can take it away. If you're running a bad job where time foundation is not a limit, okay, where you can survive, if some node is extracted from that cluster, if your job can survive that, then this is one of the best way to use discounted rates of VM to save a lot of money with your compute cost. If you see, Spot VMs are 91% cheaper than regular instances, not always, but this is mostly it's very cheaper. Cloud providers just want to utilize the ideal resources, right? If they can make money, even 20%, it's better than 0%, right? So they offer you that thing, and if you are running a 20 node cluster, you can have 4 or 8 nodes out of 20. Those are Spot VMs, and then 14 are standard VMs. Okay, even if those 8 goes away, your job can still survive, but still you have reduced the cost of your overall compute, right? How to enable that? Let's check it. To understand preemptible VMs, we'll again go back to VM machines, click on create instance. Over here, directly you will go to advanced options. Inside advanced options, there's management. You come down to availability policies. You can see the default price. By default, the standard option is selected. There's other option called spot. Okay. Once you have clicked standard, which is by default, your cost of your machine is $25 per month. The moment you select spot, price comes down to $8, right? You can see it's dirt cheap. The same VM you're getting at the 70% of the discount, 60% of discounts, depending how much discount Google is offering. The difference is standard is ideal for most workloads. Spot instances are discounted instances which are underlying on the racks of GCP, and it's sitting idle. So GCP rents it at the lower price, discounted rates. So you can utilize the benefit of being on cloud, right? That's the major benefit what GCP has. GCP gets some money for underlying resources, which is anyhow free. So you can run your fault tolerant workloads or some non-critical workloads at a very discounted rate. That's where Spot helps you. Now, what is the problem with Spot? The problem with Spot is GCP have given you the cheaper machines to run as a Spot instances, but if GCP needs those machines back, they will take it back. Okay, that's the only issue this machine has. When we read MIG, we will understand that how we can mix standard and spot and then get the sweet spot, right? And then save cost yet run jobs without any hindrance. Once you have selected spot, after selecting spot, you just need to choose that what you want to do on termination. You want to stop the VM or you delete the VM. So both are possible. Okay, any case, memory is not preserved. That's all about spot. Select, once you hit create, it will create a VM with spot instances. Okay, we add the discounted rate. That's all about preemptible VMs. Before you start reading snapshots, it's very important to understand the storage. We already have studied about cloud storage buckets. What are the rest of them? So rest of them are also your disk which are attached to your compute. Zonal persistent disks. So persistent disks are something which are not part of the OS while you're creating it. You can attach it to any VM. Okay, you can take backup, you can deattach and then again attach to another VM. That's the flexibility it gives, and this can survive your VM restarts as well. That is the point of using persistent disks. But here you have options of zonal persistent disk, which are very efficient, reliable block storage. Then you have regional persistent disk. Okay, this is regional block storage replicated in 2 zones. So this is like more reliable. The first one was only on the zonal side. The third one is local SSD. When you have to design some read-write solution, local SSD will give you the best performance. Okay, that's the highest performant disk option you have. Cloud storage is basically object storage. I have already done a lot of videos on that. You can go back and check that out. File storage is high performance file storage for Google Cloud users. Okay, you can go back and check when to use what are the benefits of using what, and these are all the options. Yeah, you can just choose it. SSD. So local SSD have the higher throughput and lower latency than standard persistent disk or SSD persistent disk. Okay, the data that you store on a local SSD persists only the instance it's stopped or deleted. Right, that's the risk of using SSD. That's why you use persistent disk. But then when you need to design a solution which have higher throughput and lower latency, then you go with local SSD and perform all your read operations on that SSD, because that will give you the fastest outcome. That's all about disks. Now let's go back to snapshots. Okay, snapshots are basically incremental backup of your data which you're storing in persistent disk. It is just backing up your disks. After you create a snapshot to capture the current state of the disk, you can use it to restore your data to a new disk. So you suppose you are saving some sort of data which you want to which you want to take backup and attach to other VM in some other environment. Snapshots will come as a savior, right? Fine, create a snapshot and then attach the disk to that VM. You can create snapshots from disks even while they are attached to running VM instances. This is important. You don't have to stop the VM. You can also schedule it. You can also schedule that after every end of the day or after every 1 hour, create a backup of the disk. This will help you survive any crash of your VMs as well. If you have a snapshot disk, you can quickly create a VM using that disk so your data persists. This mostly works like a version control system where only contains the changes from the last version, not entire full snapshot. So it helps. You can also delete your snapshot once your work is done, or you can schedule the deletion. In a nutshell, snapshots are basically to take incremental backup of your persistent disks. And how do you do that in real world? Let's go at labs and check it out. Okay, over here, to give you an example, I have already created a VM, okay, and it has a disk attached. For this, what I'm going to do to take a snapshot, first of all, I'll go to snapshot. When I go to snapshot, I'll click on create snapshot. The name I given is snapshot backup lab. Source disk I have to choose. Okay, this is the name of the VM which the disk and the VM which we created. Now I have two type of options to create this snapshot. First is snapshot. It is mainly good for long-term backup and disaster recovery. And second one is archive snapshot, which is best for cost-efficient data retention. But in this example, I'm just going to use snapshot. But you can also select archive snapshot for retaining your data. The next one is the location. Okay, if you want to keep it regional, okay, if you keep it regional, you can just use this disk in one location. If you keep it multi-regional, you can move it across US, across Asia, across Europe. Okay, of course you'll have to pay for this, but you can save your disk in a multi-regional location and share it with all the zones within US. If you do it Europe, across Europe. Okay, data transfer cost will be there, but that's the benefit. Okay, I say okay, do it across Europe. The things I selected first is the name, the source disk, snapshot, multi-regional. Click on create. You can see successfully created snapshot backup lab. Now this is the backup we have now. Now how one should use it. Okay, now suppose I have a backup of the disk which is attached to a running VM. I want to create another VM using it. So how can you use it? First of all, let's open this. Here, either you can create an instance or you can create a disk. So we'll create a disk. We'll create a disk saying, okay, this is disk 1, cloud sprint. Cloud sprint, we want to keep it in single zone. Yes, fine. US, let it be say US Central. Disk source type, whether it's image, snapshot, so we'll say it's a snapshot. The name of the snapshot is snapshot backup lab, which we just created, right? Now, which disk type you want to have, size, let it be default. Created disk now. Now you can see the disk cloud sprint one, which we have created, is being created. Let's set. Okay, so from snapshot backup lab snapshot, we have created a disk called cloud sprint, the disk one cloud sprint. Okay, you can see the source is snapshot backup lab, which is a snapshot basically. Okay, now let's go ahead and create a VM using this disk. Which for doing that, you'll come to disk attach existing disk. In here you will see that option. Okay, so disk 1 cloud sprint, you'll say read write keep disk save. So we given a name called snapshot disk to VM, snapshot to disk to VM, N1 series, and in the advanced section we choose an existing disk, the disk which we just created from the snapshot which we had taken, right? You'll click on create. Yes, you can see snapshot to disk to VM is also created. So technically, so these two VMs have the same image. So what we did, we created a VM. From VM we took a snapshot. From snapshot we created a disk, and we created again an instance, and that attached that disk to this VM. That the full life cycle we have done, and that this is how you can take snapshots, delete it. You can also schedule a snapshot. You can click here, create schedule snapshot, and as I mentioned, you can choose you want to keep it multi-regional or regional. You can have a schedule daily, weekly, hourly, and you can also choose when to auto delete snapshots. You can configure this date, and you can create a schedule. This will every day take backup as per your schedule. It will take snapshots and save it here, and then this can be used to create disks and VMs as per the need. That's all about snapshots. The last topic of this video is machine image. Machine image is a compute engine resource that stores all configuration, metadata, permission, and data from multiple disks of a VM. You can use a machine image in many system maintenance, backup, recovery, instance closing scenarios. So machine image, when you create a machine image, it will save all configuration, metadata, permission, data, and multiple disks of that particular virtual machine, and you can create that anywhere else. If you have a machine image available, you can quickly create a VM in few clicks. Okay, if your system gets crashed, you can use the machine image and create that VM, replace that VM. If you want to move that VM from dev environment to prod environment, you can do that as well, right? Let's see with one of the example how we can do that. I'm creating a VM machine image with the name machine image cloud sprint. So the VM is created. Now let's go to machine image. When you go to machine image, you can click on create a machine image. Okay, I given a name cloud sprint dash VM backup. You can write a description, source. So there's just one VM which is running, which we just created, which is machine image cloud sprint. Very important, same concept as snapshot. You want to keep it regional or you want to use across region. If you do it multi-regional, you can create it for multi-region. I'm done choosing the location. Once I'm done choosing the location, I'll click on hit create. It will create a machine image from that VM for me. Now you can see cloud sprint VM backup machine image is created. This particular backup has everything. It has VM property, metadata, permission, and data from all its attached disks. This can be today used to create an instance directly. Either you can create it from here, or you can go to the first page where you create a VM, click on VM instances, you'll click on create instance, and in here instead of choosing new VM, what you'll do, you'll click on new VM instance from machine image, and you'll see this, which the backup which we just created over here, cloud sprint VM backup, right? And you click on continue. Once you click on continue, so once you choose that, you can still change the name, the reason, the series. You can just customize it and then hit create. You'll hit create. Yes, so this VM is created now from that machine image which we created from this VM. Okay, from a VM you can create a machine image, and from using that machine image you can create a VM. This can be used for multiple purpose, promoting your VMs from one environment to other environment, taking backups, while planning your DR thing. This is very useful. Okay, that's all I had to cover for the exam for machine images. Okay, thank you very much for watching this video. If you're liking the videos, subscribe to the channel and see you in the next one. Bye bye.